Hello everyone. Let's solve the third problem from weekly contest 334. That is, find the maximum number of marked indices. You are given a zero index integer array nums. Initially, all of the indices are unmarked. You are allowed to make this operation any number of times. Pick two different unmarked indices I and j such that 2 into nums of I less than equals to nums of j. Then mark I and j. Return the maximum possible number of marked indices in nums using the above operation any number of times. Let's look at the examples. We have 3, 5, 2, 4. The answer is 2. Pick I equals to 2, that is this, and j equals to 1, that is this. This thing is happening. That means 2 into 2 is less than equals to 5. Right? So we took two indices, that's why our answer is 2. It's not possible to do with any other, right? Like we can have 2 into 2 less than equals to 4, right? But we have already used this index, right? So our answer is at max 2. Okay. 9, 2, 5, 4. If we take 2, 2 into 2 is 4, 4 is less than 5. If we take 4, 4 into 2 is 8, 8 is less than 9. So we use this and this index and this index, that is 4. So our answer is 4. In this one, the answer is 0. It's not possible to do that. 6 into 2 is 12, the minimum, right? It's exceeding all the values in the array. Now how are we going to approach this problem? Let's see. Our condition is 2 into nums of, say, array of I should be less than equals to array of j, right? So we can understand that at the same time we are going to need access to two indices at the same time, right? So can we say we can use two pointers? Okay, now in order to use two pointers, let's try to sort our array. Okay, that makes our life easier, right? So what will be the sorted order of this array? 2, 3, 4 and 5. Okay, let's not see this one. Now it becomes easier for us to look and understand, right? So for 2 we can have these values, right? 2 into 2 is 4, 4 is less than equals to 4 and 5, right? So what are we going to do? Let's place our first pointer here, okay, and let's put our second pointer at here. That is the starting position of our second half of the array. Is 2 into 2 less than equals to 4? Yes, it is. Let's have a count variable, right? Is it less than equals to 4? Condition satisfied? Yes. Let's increase our count to 2. Why? Because we used two indices. Okay. Since we use these two indices, we can't use them anymore. Let's move up. Move both of them up. 3 into 3 is 6. Less than equals to what? 5? No, it's not. Then they will move out of bounds. We'll finally have our answer, this one. Let's try with the second example. That is 9, 2, 5, 4. That is 2, 4, 5, 9. 2, 4, 5 and 9. I is here, j is here. Count. 2 into 2 is 4. 4 is less than 5. Yes. Increase the count. Both of them move up. 4 into 4 is 8. 8 is less than 9. 9. Yes. Condition satisfied. Move both of them up. Out of bounds. Game ends. This is finally our answer. So what are we exactly trying to do? If say we have these values 1, 2, 3, 4, 5 and 6. We are trying to satisfy this condition, right? So our question says that we have to count as many pairs as possible, as many indices as possible. We have to mark them. So in order to maximize that, what can we do? In order to maximize that, we have to satisfy this condition as many number of times as possible, right? So how can we do that? If we minimize this value as much as possible, then only there is the chance of satisfying this condition increases, right? Say a of I is say 1, okay, and a of j is say 4. I into 2 is 2. Let's say I increases to 2, then 2 into 2 is 4. Condition satisfied. 3 into 3 3 into 2 is 6. No more satisfied. We had two values, right? But if we initialize our a of I to say to a bigger value, so the chance of satisfying this condition also decreases, right? Because there is the chance that if we multiply it by 2, that value would exceed a of j. So in order to, for that, we will try to minimize a of I. That's why we put our index pointer I at the minimum value of what? our sorted array, and as we are satisfying this condition, we will move up and see if we can satisfy more, right? So that's what we are doing. Now let's code our solution. We will at first sort our array, right? Let n be the length, I pointer goes to the 0th position and j goes to the first position of our second half. This is the first position of our second half. Why n plus 1? Because our array can be odd as well, right? Say this, what is 4 plus 1? 5. 5 by 2 is 2 only. 0 1 2, we are putting it in the second position. Similarly here. And what about this? 3 plus 1 is 4. 4 by 2 is 2. 0 1, we are putting our j pointer here, from here, second half. Okay, and let's have a count variable 0. Now while j is less than n, if 2 into nums of I less than equals to nums of j, that is the given condition, count plus equals to 2. We used 2 indices, right? So that's why we will increase count by 2. I plus plus and j plus plus, we used both the indices at the first half and second half, so we will skip move both of them up. Otherwise we will only move j pointer. Why? Say we have these 6 values. Okay, we are initially here and here. Say this into 2 was greater than this, that means we need to increase this. So we will come here and see if the condition is satisfied, right? Very simple thing. At the end, return count. Now we can boil this down to this as well, like we can do this as well. Okay, let's submit. There we go. So our time complexity is big O of n by 2, or you can say n, and space complexity is constant. We didn't use any extra space, right? So the main idea behind this approach is we are trying to form as many pairs as possible between the first half and the second half. Okay, so that's all. If you like this video, hit the like button, share this video and subscribe to my channel if you haven't, and I will see you in the next video. Bye bye.